Number 47. Read the labels of several commercial products and identify monoatomic ions of at least 6 main group elements contained in the products. Write the complete electron configurations of these cations and anions. Okay, so now last question was at least 4. Now they're bumping it up to at least 6. That's cool. But that's okay. All right, so we just have to find 6 main group elements contained in the products. Now, at this point of the game, in Adam's the chemistry textbook for OpenStax, you have not learned how to do nomenclature, especially for ionic and covalent molecules. So I wouldn't really expect you to know how to identify monoatomic ions on your own. I think this question got slipped in from the other textbook, just the chemistry textbook from OpenStax, because they learned nomenclature before they learned electronic structure. So I'm just going to give you some of the main group elements that you might find in the products. All right, but you should know that cations always lose electrons and anions always gain electrons. Cations are always positively charged because remember electrons are negative, so if you lose negative, you're more positive, and if you gain negative, you'll be more negative, so anions are normally negative. Majority of the time, cations will be your metals, and your anions will be your nonmetals. That can change though, especially when you meet the beast organic chemistry, but that's neither here nor there. By the way, let me know in the comments if you have to take organic chemistry. It's my favorite, but I think I'm a little weirdo, but that's okay. So yeah, let me know if you're taking Orgo for like the MCAT or, the DAT I think they do need that. But anyway, yeah, the PCAT, let me know what you're taking it for. Okay. So, main group elements are anything that's not in the transition metals. So it's basically 1 and 2, and then 13 to 18. So these are your main group elements. So between these two sections, these are your main group elements. So it could be from hydrogen to all the way down here, and then from all the way down here to here. These are your main group. Or I'm just drawing it a little bit sloppy because we got a lot of things to do. So you could pick literally any metal or any non-metal in there. I'm going to pick sodium, calcium, aluminum, fluorine, chlorine. How many is that? That's 5. And then let's pick, I don't know, silicon? Sure. All right, so let's back this up. Actually, instead of silicon, let's just do carbon. It doesn't really matter, but you could just pick, 6 out of those main groups. So what I'm going to do now is I'm just going to erase this because we have a lot of stuff to do, and we're going to mark this up. In the meantime, if you don't have a periodic table out, go get one because you're going to mark up your periodic table as well. Now, in the last question, we went into depth about how to separate the periodic table to do electron configuration. I'm just going to do the, faster version because if you guys need more time, just go to number 46. It's all there for you guys. Just know that when we're doing electron configuration, don't include helium over here. Include it over here because helium really is, and there's a 2 here, atomic number 2. Helium is really in the s orbital, the s subshell, and not the p's. So if I can highlight all of this. These are all of your S subshells. So I'll put that over here. So from here to here, this is your S's. From here to here is where all your electrons in the P subshell are. So if I just draw this a little crazily, we have that. So this is the P. And then in the place where, between the S's and the P's are the D's. So all of this is the D's. Down below those 2 columns are the F's. We will not be getting into the F's because we're not that far down. Our atomic numbers aren't really that far down. So we don't have to worry about that for now, but I'm sure questions will come up later. Okay. So, We just need the cations and anions. Okay, so for the first one, we're going to do Na, sodium plus 1. This could be found in salt, right? Table salt is NaCl. So Na plus 1 would be the cation for salt. Now, how do you do electron configurations for either anions or cations? The first thing you're going to do is find electron configuration for element without charge. So you pretend that there's literally no charge and you do the electron configuration if it didn't have a charge. Then you adjust electron configuration to fit charge. So you only manipulate it once you have it to the correct charge. Now, how do we do an electron configuration? You always just follow the atomic number. And the atomic number is the whole numbers that are on the periodic table. So for example, you'll always start here. This is always your starting point. All right? So you always start with 1. Look on your periodic table. The numbers are going to be bigger for there. So 1, helium is 2, right? Then you got to follow. So you would go down here because lithium is 3. Then to 4, then to 5, etc., 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 11, 12, 13, 14, etc., etc. All right? So just always follow the atomic number. Now, disregard the elements. Just think of it as boxes with electron in it, 1 electron. So basically, you're like playing Pac-Man, and you're just collecting the dots, right? How Pac-Man goes along in his maze and collects the dots. That's basically what you're doing here. You got to go follow the atomic numbers and collect the Pac-Man dots until you reach the number of your element. Now, for sodium, we need to get all the way down here. So you got to start at 1 to get all the way down to number 11. Now, one other thing that I want to say is that the S's will always start with 1s. So this first group is 1s. This will be 2s, 3s, etc., etc. So the S's start with 1. The P's will start with 2. So this will be 2p, 3p, 4p, etc., etc., etc. So they start with 2. So if the S's start with 1 and the P's start with 2, what do you think the D's will start with? This first D right here would start with 3. So this would be 3D. So just always remember that. And if you need to write that on the periodic table before your test or quiz, do that. It will help. So now all we got to do is just follow from 1 all the way down to 11, and then we will adjust. So we're at the 1s subshell, right? Because we got to pick up both boxes, right? With the dots, we got to pick up the Pac-Man dots. So that would be 1s, we name it. And then in the upper right-hand corner, you just say how many boxes and how many, dots, electrons you collected. So you collected both of them. So that would be 2. Then you move on. Follow the atomic number. Now we're down to 3. So that's in the 2s. So this would be 2s. And we have to pass both lithium and beryllium, both the boxes, because we got to get to 11. So that's a 2 as well. Then you move on. Now you're at number 5. So this would be 2p, because that's the name of that. And we have to pass all 6 of them if we counted 1, 2, 3, 4, 5, 6. So we had to pass all 6 boxes, so that would be 2p6. And then finally, sodium, we have a 3s, and we only collect this electron. We do not collect this one. That's too many. So this would only be a 1. Now we adjust. So right now we found the electron configuration without the charge, and now we adjust. And how do we do that? We always take or add electrons to highest shell. And remember, the shell is just the n number, and the n number is always the large number in the front. So in this case, it's a +1, which means that I have to take away 1. So look for the highest n number. It's the big number in the front, which would be a 3. And there's the 1 electron, so this whole thing would get kiboshed. So Na plus 1 would just be 1s2, 2s2, 2p6, and that's it. Box it off. That's your answer for the first one. Now let's do another one. Let's do calcium, right? Calcium usually is a 2+ charge. So we got to follow the atomic number, play the Pac-Man game, right? Or if you're as old as I am, we used to have chutes and ladders. It's kind of like you had to follow that, that rhythm to get from number 1 all the way down to the last part to win the game. So it's the same kind of thing. But yeah, so calcium is found in the milk, right? And they fortify almond milk or oat milk or regular milk. So it's all in every milk that's possible, dairy or non-dairy, whatever you choose. So we got to get to number 20, but we still got to start with number 1. So it's going to basically look exactly the same up until this point, because we're just going to keep moving on. So let's start. We had to start with number 1, that's 1s. You had to collect both boxes. Now we're down to number 3, that's 2s. We collect both boxes. Now we're over at number 5, that's 2p6, because we collected all 6 of them. Now we're down to sodium, that's 3s. Now we collect both of them, so that's a 2. Now we're over here. 3p is a 6, because we have to pass both of them. And now we're over here, this is 4s. And now we collect both of them because I got to stop at calcium. So that's 4s2. Now adjust. You want to take away 2 electrons. So take it from the highest n number, the biggest number in the front, which is the 4. And there's that 2. So you just get rid of all of it. So calcium 2+ would be 1s2, 2s2, 2p6, 3s2, and then 3p6, that's it. Box that answer off. That's the final answer for that one. Okay, now let's move on to aluminum. Aluminum is obviously found in aluminum foil. So usually Al is a +3. So we just got to keep playing the game until we get to number 13. So we got to start at hydrogen. That's 1s2, 2s2, 2p6, right? Because we got to collect all of that. Now we're at number 11. We're at 3s2. And now we just need to collect this 1 dot over here. So that's a 3p1. Now let's adjust. It says that they want a +3, which means that we need to take away 3 electrons. Now here, there's 2 boxes or 2 shells that have the biggest number. So when that happens, you work from the back to the front. So you go from right to left, technically. So get rid of this 1, right? There was 1 electron here. And here's the other 2, because we need to get rid of a total of 3. So bye-bye. And now you just write what you got left. So it would be 1s2, 2s2, and 2p6. Box that off. That's your final answer for that one. Let's move up top now. Let's go with carbon. Carbon, well, the diamond form of carbon is not a cation nor an anion, but basically anything that you eat is basically is made up of carbon. It's made up of carbon and hydrogen, right? Because anything organic is based off of carbon and hydrogen. So let's just say that this carbon was a, we'll say that it's a +4. Actually, we've been doing a lot of pluses. This one we could actually make a -4. So this one means that I'm going to gain 4 electrons. So let's go. We first write the electron configuration for the electron without the change. So I got to go to number 6. Start with hydrogen. So 1s2, then 2s2. Now I'm over at 2p, and then 1, 2. So that's 2p2. But now I have to add 4 electrons. And remember, a p can have a max of 6 electrons, right? If I count these boxes, 1, 2, 3, 4, 5, 6. So you just add on to where you left off. So if I just add the 4 here, this would turn into a 6. And that's perfect because the P maxes out at 6. So it would be 1s2, 2s2, 2p6. Box that off. That's the final answer for carbon. 2 more. Let's do fluorine. We'll do fluorine over here. Fluorine is usually a -1. It's seen in your toothpaste as fluoride. So we got to get to number 9. Got to start from the beginning. Started from the bottom, now we're here, right? So 1s2, 2s2, and now we're at 2p, 1, 2, 3, 4, 5. The -1 tells me that I need to gain 1 electron. So the 5 plus 1 will turn into the max of 6. So F -1 would be 1s2, 2s2, 2p6. Box that answer off. And then last but not least, let's do sodium up top here. Actually, not sodium. Chlorine. So chlorine is down here. Chlorine is the counterpart for sodium that brings us salt, sodium chloride, table salt. So Cl -1. But nonetheless, -1 means that we need to gain 1 electron. Start from the bottom and get all the way to number 17. So 1s2, 2s2, 2p6. Right now we're over here for sodium. So 3s2, and then 3p, 1, 2, 3, 4, 5. We need to gain 1. We're adjusting. So the 5 plus 1 will give us the maximum for the p's. So if I just erase this and put this as a 6, that would be the answer. And that's it. Whew. Crazy, right? If you guys can get this one, you are good to go with electron configuration for your test quizzes, homework coming up, whatever. If you haven't done number 46, go try that one out. And there's more questions coming up, so I'll be here every step of the way. Thank you guys so much for tuning in. Thank you for coming here to get help with the OpenStax textbook. I love to help you guys, and I try my best to help you as much as I can. Hopefully this makes sense. Let me know in the comments how you think, or what you think about this. If you want to support the channel, please hit the subscribe button. That would help us out tremendously. And like this video. Thank you so much from the bottom of my heart. I will see you guys on the next question. Bye-bye.